video is on chapter 18, lesson number 2 on measures of central tendency. For measures of central tendency, the vocabulary here says that a value that describes the center or middle of the data. So your measures of central tendency describe the center or the middle of the data. You have 3 things here that you should be familiar with. The first one is mean. There's a symbol that right next to mean on the right. It's the mu. It's a Greek letter, mu, and it means the average. There's also a symbol on the left, which I'm going to talk more about when I get to the calculator, but it also means the mean. The median is the middle value or average of the two middle when the numbers are listed in order. And then, of course, mode is the most repeated value. Now, to find the mean, median, and mode for a data set, it's very simple. If you want to do this by hand, very quick and very easy. You're going to, for the mean, we add all the numbers and then we divide by the number of numbers. So using the calculator, I'm going to add all the numbers in the data set, which were 58 plus 53 plus 59 plus 51 plus 46 plus 35 plus 51 plus 58 plus 60. And then I'm going to divide by, there are 9 numbers. So I'm going to divide that by 9 to get 52.3 repeating for the mean. Your median, again, is the middle or the average of the two middle when the numbers are listed in order. So we would have to list these in order first. The smallest number is 35. And then would come the 46, 51. You might even want to mark these out as you go. 51 occurs again. And then 53, 58, and then 58 again, and then 59, and 60. So there's my 9 numbers listed in order. The median is going to be the middle or the average of the two middle. Since there's an odd number, there is a middle, which is going to be 53. And you notice when you were putting those in order that there were 2 numbers that occurred twice. So I have 2 modes, and they are 51 and 58. Now, real quick, I do want to show you how to do this in the graphing calculator. Not that that was hard, but to show you really quick in the graphing calculator how this is going to work. You're going to go to Stat, you're going to click on Edit, and you're going to clear out anything that's in your history there. And I'm working on number 2. I'm going to put all those numbers in: 21, 10, 27, 24, 15, 7, 19, 24, 31, 15, 11, and 24. So let me make sure I got those in there correctly. Again, the only way to make sure is to just go through them really quick. I've got them all in there right. And then I'm going to hit Stat and Calc. Number 1 says 1 var stats. I'm just going to hit Enter. And I'm going to continue to hit Enter until it calculates. And my screen's going to fill it with a lot of information. So the first thing that you see here is the mean. So X with a bar over it is the mean. The second thing in the list is the sum of all of your numbers, which would have been 228. And then, of course, that squared. I don't remember what the SX is. I'll have to get back with you on that. The next one is called standard deviation, which we'll learn about in the next lesson. N equals 12, meaning that there were 12 numbers in the data set. The smallest x is 7, and then the quartile 1 is 13. The median is 20, quartile 3 is 24, and then the biggest number is 31. So we were able to find the mean and the median using the calculator here. So the mean was 19 and the median was 20. Now, the only thing that the calculator did not do for you was identify the mode or modes if you have more than one. So you would have to kind of go through the numbers yourself and identify anything that occurred more than once or more than twice. And it looks like, looking at my numbers, that the number 24 is the only mode and it occurred 3 times. So that's a quick way that allows the calculator to do that work for you. The next thing I want to talk to you about is measures of variation. Measures of variation means that you've got a value that describes how spread out a set of data is. It's also called measures of dispersion. The first one that we're going to talk about, the first measure of variation, is called the mean absolute deviation, or MAD for short. It is the average distance of each value to the mean. So unfortunately, the calculator will not do this for us, and we are going to have to do this ourselves. I'm going to look at example number 4 to do this example. Again, the MAD, by definition, is the average distance of each value to the mean. So the mean is involved here, and I need to find the mean for this data set on number 4. So we're going to add, I'm just going to add and divide in the calculator. I'm not going to use a list. I can do this in the calculator just as fast, just by doing what I did before. And you can certainly pull up a fraction and make this go even faster. So 14 plus 18 plus 16 plus 19 plus 21 plus 14 plus 15 plus 23 plus 21 plus 19. And then there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Again, I'm just checking really fast that I've got everything in there, and I do. And so my mean is 18. So my mean on number 4 is 18. From there, let me go back to this definition. The MAD is the average distance of each value to the mean. So what it's asking us to find is the difference, or the distance, that each of those is from the mean. So we're going to take and look at each number in reference to the mean. So if my mean is 18 and the first digit is 14, they are 4 numbers apart. So we're going to take that difference for each term in the data set. So 18 and 18, there's no distance between those two. From 16 to 18 is 2. From 19 to 18 is 1. From 21 to 18 is 3. 14 to 18 is 4. 15 to 18 is 3. 23 to 18 is 5. 18 and 21 is 3. And 18 and 19 is 1. Now notice that in that situation, I ignored negatives. You're just looking for the distance, and distance is always positive. And again, you're going to divide that by how many numbers we should be looking at, which is, there are 10 numbers in the original data set. So 4 plus 0 plus 2 is, there's about 26 divided by 10. And you could totally do all that in the calculator if you wanted and get a MAD of 2.6. Now, I do want to talk to you really quick. I have a lot of information written here on the left about MAD. MAD will help determine whether the mean is a useful indicator of the values within the set. A large MAD indicates the data is spread out from the mean. A small MAD indicates the data is more clustered and more predictable. So I'm going to give you a for instance. So on number 3, I know that the MAD is 8.56. So when you compare a MAD of 8.56 to 2.6, what that means is that the data in question 3 is more spread out. Your MAD is being affected by what could potentially be what we call an outlier. So the 60 is a lot different than those other numbers. So that's why the MAD is a little higher. In question number 4, most of those are in the teens or the low 20s. So they're kind of more clustered together than example number 3. All right, moving on to the next section, we have 2 more measures of variation, and one is called the variance and one is called the standard deviation. The variance is the average squared distance of each value to the mean. So that's a very similar definition to MAD. The difference between MAD and variance is that when we find that distance or that difference between the mean and the number in the data, we square it and then find that average. Your standard deviation is the square root of the variance. And that is the most useful measure of dispersion. You hear more about standard deviation than a lot of other things. What do the numbers mean? So the first bullet here says that a lower standard deviation indicates that the values are closer together. A higher standard deviation indicates that the values are more spread out. So same thing with MAD. These are all very similar in that they are describing the dispersion or how far apart the numbers in your data are. So for example number 5, I'm going to show you how to do this in the calculator. Actually, on number 5, I'm going to show you how to do this by hand. And then on number 6, I'm going to show you how to do it in the calculator. On question number 5, if we're going to do this by hand, we have to know the mean of the data. And I'm just going to tell you that the mean is 92. The mean, which is your mu, is equal to 92. And again, you would have gotten that by taking your calculator, take 85 plus 88 plus 91 plus 96 plus 100 and divide by 5. Because there are 5 terms in your data set. And then to find your variance, we are going to do the difference, the average of the distance squared. So 85 to 92, that's 7, and we would square that. From 88 to 92 is 4, and again, you need to square it. 91 to 92 is 1. 96 to 92 is 4. And then 92 to 100 is 8. And again, we're going to do the same thing and divide by the 5. So if I put that in my calculator, and I do 7 squared is 49, plus 4 squared is 16, plus 1 squared is 1, plus 4 squared is 16, plus 8 squared is 64. And again, we're dividing by 5. That gives me a variance of, let me change that to a decimal, 29.2. That's our variance. And then to find the standard deviation, I have to take the square root of that. So I'm going to take the square root of the 29.2, and I get 5.40 for the standard deviation. Okay? So really fast in the calculator, we're going to do like we did to find the mean, median, and mode on the other example, and you're going to go to Stat, Edit, Clear, and then enter your digits. So I'm on example number 6. I'm going to put in the 3, 4, 7, 8, 11, 12, 12, 15, and 19. 3, 4, 7, 8, 11, 12, 12, 15, and 19. stat, calc, enter, 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 enter. And you'll see here that it gives you the standard deviation. Now be very careful that you recognize this for what it is. This 4.86 is the standard deviation. 4.86 is the standard deviation. Now, the definition of standard deviation is it's the square root of the variance. So if I've got the standard deviation and I want to get the variance, I just have to take that and square it. So I'm going to actually use a couple of extra decimal places. 4.8636. 4.8636. 4.8636. Whoops. And then I'm going to square that to get 23.65 for the variance. And that is how we use our graphing calculator, or again, if you prefer to use the by hand method for finding your measures of central tendency as well as your measures of variation.